Alright, welcome to this talk. Houston, we've got a problem. How to debug your pipeline in Tekton. I am Vincent Demeester, senior principal software engineer at Red Hat, and I am one of the lead of the Tekton project.
And I'm Vibhav. I also work at Red Hat and I work on a lot of Jenkins stuff and Tekton as well. And yeah, today we are going to talk about how to debug your pipeline in Tekton.
Right, so let's go through the agenda. First, we'll define a little bit what do we mean by debug in debug what. Then we'll go rather quickly on what is Tekton in a nutshell. Hopefully you know already a bit what is Tekton when going to this talk, but if you don't, this will be a really quick introduction to Tekton. Then we'll do a little bit of magic in Russian dolls, explaining how all this works. Then Vibhav will do a demo, and we'll finish with the next steps after this demo, after this work, what will be the next steps. So first, debug what?
So let's talk a little bit about debugging. Debugging is the process of identifying and removing errors from computer hardware and software. And in this case, we'll be talking about debugging, but it'll be in terms of pipelines. And debugging pipelines themselves. So, what do I mean by like debugging pipelines, and what are pipelines? Uh,
So
Vincent?
pipelines usually is a linear sequence of specialized module used for pipelining. Basically, this means you do a task or an action, then another action, then another action, and some can be in sequence, some can be in parallel.
Yeah. So, why would we ever want to debug our pipelines? Now, if there is a pipeline which works on your machine but not on the CI, it's very hard to understand why it's not working on the CI because you would need to understand what is the environment the pipeline is running in, and that would be the CI environment, and you would need to get access to the CI environment and understand these things. So, debugging pipelines could be helpful in this way, where you just get access to the CI environment and figure out why it's not working on the CI. But then there are also times when it only runs on the CI, and you can't run it on your machine because of resource constraints, and you will have to debug your pipeline while it is running and go to a particular part of the pipeline and debug it there. Then while you're debugging that same pipeline on the CI, there is a possibility that you won't be able to fix it if you are just passing some parameters around, and you never understand where the error is happening because you run the pipeline, you see the error, you fix it, you run it, you see the same error, you fix it again, and you keep doing this till you get really frustrated, and you probably want to leave your job at that point, but you can't do that, and you have to keep debugging pipelines as they are. But there are better ways to debug pipelines, and instead of doing it in this way, and some CI tools allow you to debug pipelines while they're running, and they provide great support for this. Some of these examples are CircleCI, Build, Travis, which do this very well. So getting inspiration from this, we in Tekton figured that we could do this in Tekton as well.
Right. So how how would you debug pipeline? So this is kind of explaining what we will do in Tekton and what other tools kind of do in some manner. So debugging pipeline, what do you want for it to do? One first. You want to be able to pause the execution of your pipeline at demand, so anywhere if the user wants to, and or in case of a failure. So some steps or some action failed, I want to stop the execution there and be able to drop in. So we want to allow the user to drop in directly in the CI environment, so it sees what files are there, what processes are running, anything really that could help them debug more what happened and why it failed, and probably also re-execute some stuff in the context of the environment, the CI environment. And of course, once we allow the user to drop in the CI environment, we want to allow him to continue or break the flow. So if he feels like he knows what's happening, he fixes it manually for this run and wants to see if there's anything else that that will fail later, he can continue it with success and let the pipeline continue running. Or if he knows how to fix it, he's pretty sure it's not gonna fail after, he can just go ahead, fix it, and thus he wants just to not consume too much resources and break the flow, finish the pipeline as it would have been without the debug. And how we will do this in Tekton, we'll dig a little bit more how we do this in Tekton, but this is based on TEP, the number 42. So TEP stands for Tekton Enhancement Proposal, and this TEP is about adding breakpoint on failure for steps inside a task run. This is focused on task run to start the work, but this TEP is going to extend more and more as we go. So first, let's go quickly on what is Tekton for those who are who do not know what is Tekton or have a really general idea of it. If you do know Tekton very well, the next few minutes will probably be a little bit boring, but it's okay. So what is Tekton in a nutshell? Tekton is an open source project that aims to provide a set of standard and shared and shareable components for building a Kubernetes-style CI/CD system. This is governed by the Continuous Delivery Foundation, the CD Foundation, which is a kind of a cousin of the CNCF. And contributions are coming from literally everywhere in the world and lots of companies. Some of the most important ones are Google, Red Hat, CloudBees, IBM, Pivotal, and D2IQ. There's many more. It's a really highly active community right now.
So there are a few concepts in Tekton that really help to understand how the Tekton pipeline itself works. So these would be step, task, pipeline, task run, and pipeline run. And we couldn't think of these resources in two different kinds. The first one would be the definitions. Second would be the executions. Among the definitions, we've got task and pipeline, where a task is a list of steps that run sequentially in the same pod, and each step is by itself running in a container. And a pipeline is a graph of tasks with inputs and outputs executed in a certain order. And a pipeline, and when we say a graph of tasks, we mean that these pipelines can be made of can be made of different tasks together, and these can be pre-existing tasks, new tasks that you can create right in the pipeline itself, and then you can just basically compose different tasks together to form a pipeline. And this really shows the composability of Tekton itself when it comes to creating pipeline. And to run each of these tasks in pipeline, to have these as reproducible as possible, you can just define these tasks and pipelines once and then run their equivalent run resources, which are that you have a task run for a task and you have a pipeline run for a pipeline. So if you want to run a task with certain parameters, you would basically create a task with a task run, and when you create this task run, you can give any parameters that you want the task to run with. If there are some other parameters you would want to run the task in the future, you can do that as well. You just have to provide different parameters in that case. And the same is the case with PipelineRun. You already have your pipeline with the tasks which can run either in sequence or in parallel, and you just provide a pipeline run in which has all the inputs that are necessary for the pipeline, and then you can just run your pipeline run. And in this way, you can just keep testing your tasks and pipelines with different parameters, and you can compose different pipelines with multiple different tasks, and you never have to have to write different pipelines every time, even if you're using the same functionalities you before. So Tekton is in this way like very reproducible and composable, and it makes it easy for the users to just kind of get down and start making pipelines easily if you have a certain set of tasks. And a lot of these tasks are present in the task catalog, so the user can just start building their own pipelines. So let's talk about what a task actually looks like. Okay, so here in the task, we've got a spec and there are steps which we can define in the task. And we are going to focus on this task, not this task in particular, but we're going to focus on tasks and task runs and trying to debug them. So in the future, we should also be able to debug pipelines, pipeline runs. Uh, so for now, we are going to look at this task and create a task run from this task, and I'm going to try and debug it. So let's actually understand what debugging looks like and how we've gone ahead and implemented it. For that, we look at something called the Russian roll entry point hack. And Vincent, you'd like to go ahead with it?
Yeah, so let's dig a little bit about the Rishendal debug. So we use Rishendal as a reference, mainly in reference to the talk that Christy Wilson and Jason Hall from Google did in 2019 in KubeCon, where they described a little bit what Tekton was doing, what magic Tekton was doing to be able to run containers in sequence inside a pod. In a gist, what we do. Let's just first define what we mean by entry point, and then what this hack is all about in one slide. So an entry point in the container world is whatever binary or command that is gonna run when the container starts. And the talk that Jason and Christy did, resumed in one slide, is we do overload the user entry point, so either the entry point that comes from the image or the one that the user provide. We override this one with our own one we control. This is a binary called entry point. So what Tekton does when it schedules a pod for a task, it's copying itself, the entry point, inside each and every container, so that we know what we execute. Then we do change the entry point to be our own entry point, and then in arguments whatever was the original entry point. So if the user didn't specify anything, we'll check what was the image entry point, and then we will append it to our arguments. If the user provided something, we will append it to ours. So for example, if the user wanted to do a ls-l as entry point, in a really simple way, this is going to be executed as our entry point, then ls-l, and thus we can control whatever it gets executed. And thus the third step is going to be our binary is waiting for some signal to start. We are using files from previous steps, if there's any previous. And then if we got the signal, we just run the initial command that the user provided. And then when it's done, we can gather the result, so gather if it failed or not, which exit point it was, and signal the next step. So in the natural normal flow, if the command failed, we will write that it's an error, and the next step entry point will know that the previous step failed and skip and so on for all the other steps. So this is how the entry point works. If you're interested in digging more, I'll let you watch the talk after. But for our debugging purpose, we needed to enhance this, and this is where the debug breakpoint story happens.
So, as Vincent, you said, like to uh, actually start debugging and providing the feature for debug, what we've had to uh, kind of expand this entry point hack and a little bit flip it over its head and use this hack to actually control the life cycle of the steps itself, so that when a step is executing and it fails, the step should stop at the failure and not stop the execution of the uh, task run itself. And the user should be able to go into the environment and then debug it and troubleshoot and figure out what's the issue, and then go back and fix the issue that is there that they found. So for this, what we do is, first of all, we mark the task run as debuggable by adding the debug spec, and also um, adding where we want the breakpoint to be. On failure over here is a dynamic breakpoint, which basically stops like the task run on any step that fails. So how many of the steps fail, the step would be paused at that point, and the user can basically gain access to the environment of the step at that point. And what is done is, when the user gets environment access, they can debug, do whatever they want over there, and then they can after that continue the step from there by marking the step either as a success or a failure. So to continue and break the breakpoint uh, and mark the step as the failure, we provide scripts which help do all these things. So we provide a debug continuous script, which basically marks the step as a success and then breaks the breakpoint. And the user can also mark the step as a failure by using the debug fail continue script. And the step would be marked as a failure, and in the end, the task run would also be marked as a failure. Uh, so when this execution is complete, the user can basically go ahead and uh, kind of get get an idea of what exactly failed, so that they can go back to the task run and fix it over there. So yeah, um, now we'll actually look at how to do this in uh, in an actual demo, and let's go ahead with it. Okay, so we are running Minikube and with Tekton installed, and you can see that there is a Tekton controller and webhook pods over here. And what we are going to do is we are going to run a task run which contains a task spec, so we don't have to create a different task. And this is going to have a task which is going to write a file and then start it and then read the file. And let's see how that goes. So this and somewhere along the way the task is going to fail, and we'll probably figure out by the end like how we can debug and fix the task. So let's go. I'm going to go ahead and create this task, which is called step script bash. uh, and then you can see here that the task run has been created, called step script and a generated name. And it's in pending mode because the pod is initializing. Task run pod is initializing. And over here, we should be able to see the task run logs which come up. So we'll just wait for a sec till that comes right up. Okay, so you can see the task run is running, and but you can see in the logs also that we've gotten an error in the stat step, which says that cannot start shared data new write, no such file or directory. So I don't know what's going on here. Let's go back and check in the task run itself, like what happened. Considering like we are on failure right now, we can see this debug steps saying that skipping writing to the post file is related to debug. And what we'll do is we will get into this pod and go to the step start container, which is basically step dash step name. That is the container name format for this. So this is a step that we are going into. We're going to see like what is going on. So we are using the Ubuntu uh, image here. So there is the bash shell. So we are able to use it. So we are in the bash shell in the container right now. And what we are going to do is we are going to check cannot start shared data new write. So we're going to check if new write is there or not, just in case. So there is no such file or directory. Let's just go ahead and share data if we can figure this out. So we are in shared data. Oh, it seems like there is data in the shared data. I'm going to read it. Okay, there is something, there is awesomeness inside. Now what we're going to do is we're going to uh, okay, now we know that the data is in data file and not in new write file. So we are going to go to the task run and I'm going to try and debug it. So the task run that we ran was the step script bash. In the step script bash, so the second step, so the write seemed to work well, and the stat is doing a stat on shared data new write, which is wrong because it seems like it's writing to data and not new write. So I'm going to go ahead and fix this right away. And then considering that at the end in the last step we are reading shared data. So I think it should work. So we'll just mark this step as a success for now. So let's go back to the container and then mark this task run as a success. So I'm going to, so how do I mark this as a success? So I'm going to go to Tekton debug scripts. And in the scripts, we have, so these are the debug scripts which come along with the debug spec, and the user can use to either mark the step as a success or as a failure and close the breakpoint at the same time. Uh, so I'm going to go ahead and run the debug continue script over here. And yep, so the pod terminates and the task run is marked as a success over here. And you can see that we find read awesomeness over here as well. So basically the task is passed with success. Now let me just go and test out if the check that we made, the debugging that we did came to fruition after changing the new write to data. Uh, so I'm going to run the same task run again. Uh, so we got this task run right here. It's the pod is initializing, it's running. It'll start running soon, I hope.
Right. So as we saw, and as we are seeing it right now, we were able to quickly get in the container and see what was inside, and it helped us see that we were looking at the wrong file. So yeah, this was pretty useful. Vibhav right now decided to mark the step as the step in the task as a success because we knew the next step would succeed. But we could have done the opposite, like doing marking it as fail and just have a new one. All right, so this is more or less the current status of our proposal and our work. Let's see what are the next steps for this. So there's a few things that we need to enhance or add to have a more complete debug feature. One thing is right now there's a kind of shortcomings, which is if you are using inside your steps an image that doesn't have a shell, then the debug scripts won't work. You won't be able to continue or break the flow because we need a shell to do that. One thing that we would like to provide for this reason and for other useful reason is for Tekton to be able to provide its own shell, probably as part of the entry point itself, either the same binary or using the entry point injection ACK to inject another binary. This would be useful because then no matter what image is used inside your step, you could debug it, but it would also mean no matter what image you use, you could use the script feature of Tekton. Then we also want to support more modes or breakpoints that the user can provide. We demoed the only mode that is currently supported, which is the on-failure mode. We would like probably to add more things like debug on each steps or specify the steps that we want to debug. Those kind of things we need to support, and probably the same on the pipeline itself. So be able to say I want these and these tasks to be debuggable, but not the other ones. In addition, we would like probably to go forward. We kind of are waiting for feedback of the community, but we are thinking of in the future being able to actually do the software debug of a process running in the CI directly from your IDE. So the flow would be something like I do run my pipeline. There's some end-to-end test that runs and my service is running and is opening a port to debug. I would like to be able to hook my IDE on this running process somewhere and just do my usual IDE debugging feature on there. And of course, probably one of the most important next step is a better user experience. So we would like to make it even more easier for the user to actually debug his steps or his pipeline. So integrate it with TKN, the Tekton official client or dashboard, where you could just see it failed and it's in a debug. It's in a debug mode. So just do TKN debug and get dropped in, or from the dashboard, just okay, it's in debug mode. Just drop me in the shell. And of course, more tooling integration. So integrate it directly within your IDE, being IntelliJ, being VS Code, etc. And those are the next step that we are seeing right now. Of course, we are open to any feedback on this because it's not set in stone. It's going to be an experimental feature to start with. So yeah, we would like to hear from you. And yeah, thank you for attending this talk. As other VLTool talk, we are available on chat for questions. So yeah, thank you for listening to us and watching this talk.
Thank you, everyone.
Take care. Bye-bye.
Bye.